Hi guys, this is Dr. G here, and in this video we are going to talk about Grignard reagents. So Grignard reagents are actually one of the very important reagents in organic chemistry. Grignard reagents are one of the most important reagents in organic chemistry. Let me tell you why. Because Grignard reagents, one, are highly reactive. Two, they can add carbons easily by using many different other functional groups. Okay, so Grignard reagents are actually very reactive many other functional groups, and then it can add carbons to your organic compound. Okay, it can add carbons to your organic compound. So in the future you will see a lot of reactions that are associated with Grignard reagents, and you will always remember this. Okay, if you wanna add carbons to your organic compound, you will always consider using Grignard reagent, at least in paper, on the exam, or in theoretical techniques. Okay, so practically this reaction could be a little bit difficult, but of course it is very easy to use on paper, and also it is a good technique to use if you ever wanna add carbons to your organic compound. So in this video we are simply going to talk about how to make Grignard reagents. Okay, in this particular video we are going to talk about how to make Grignard reagents, and then for this one we will use alkyl halides. So in order to make Grignard reagents you are going to need alkyl halides, and also in the last part of this video I will talk to you about a very simple reaction that Grignard reactions will undergo with alkyl halides. Okay, so in this video we are going to talk about two things. One, how to make Grignard reagents from alkyl halides, and then two, how Grignard reagents react with alkyl halides. Okay, so those are the two things that we are going to cover. So synthesis of Grignard reagents has to use a lot of caution. Okay, mainly because Grignard reagents are extremely reactive. They are extremely reactive, and also they are susceptible to moisture and acids. Okay, so they are extremely susceptible to moisture and acids. So you are going to need dry conditions whenever you are making Grignard reagents. So if you are reacting Grignard reagents with something else, you are always going to want to have a dry environment. Okay, they are very sensitive to even humidity or moisture. Okay, so in order to make Grignard reagents you are going to need an alkyl halide. Okay, so basically you can use any alkyl halide. It could be a primary alkyl halide, a secondary alkyl halide, a tertiary alkyl halide, or even alkenyl or aryl. Okay, any of these will work. Okay, so whenever you have an alkyl halide you will let's call them Rx. Okay, so let's call them Rx. So the R group could be any one of these five groups. Okay, so the R group could be primary, secondary, tertiary, or alkenyl or aryl. So whenever you have an Rx or an alkyl halide, you will treat it with magnesium under dry conditions. To maintain dry conditions, most people use ether. Okay, so you will react alkyl halides with a metallic magnesium in the presence of dry ether, and then you will generate a Grignard reagent. So this right here, this magnesium complex, okay, RMgX, this complex is known as Grignard reagent. But sometimes you can also write Grignard reagents like this. You have the R minus anion, okay, R anion, and then the Mg X as a cation. Okay, I think this is a better way of writing Grignard reagents. Okay, so you will have the nucleophilic R group, you will have the nucleophilic R group, and also the MgX. Okay, this right here will be your nucleophilic group. All right, so this is how you make Grignard reagents. Once again guys, okay, so in here magnesium is going to be positively charged and carbon is going to be negatively charged. So this carbon, okay, the carbon that is directly attached to magnesium or associated with magnesium is going to be an excellent nucleophile and also an excellent base. Okay, it is both an excellent nucleophile and also it is basic. Okay, it is very basic, so it is highly attracted to uh, hydrogens, okay, or acids. Okay, it is extremely susceptible in acidic environments, so that is why we are even keeping it under dry conditions. Even a weak acid like water could basically destroy your Grignard reagent. Okay, so in this Grignard reagent you are going to have this carbon ion, okay, which is your nucleophile. All right, so let's see if you could do this worked example. Okay, all you need to worry about or think about is that using the Grignard reagent in this synthesis method. Okay, and then always keep in mind Grignard reagent is extremely basic and it is a really good nucleophile. Keeping that in mind, see if you could solve this worked example. You may pause the video now. All right, so in this worked example, you need to mention how a halogen substituent or alkyl halide can be replaced by a deuterium atom. Okay, so you are going to replace this halogen with a deuterium. Okay, and how do you do this? So let's see. So if you want to get a deuterium is basically just like hydrogen. It is an isotope of hydrogen. Okay, so if you want to get a deuterium, if you want to get this deuterium, you can easily go through the Grignard reagent. Why? Because if you have a Grignard reagent, you simply have to put D2O. Okay, D2O, and then the Grignard reagent will be converted to a hydrogen, or it will basically, the carbon ion will substitute a hydrogen from D2O, which is basically deuterinated water. Okay, so you will synthesize a Grignard reagent. Okay, so this will be your Grignard reagent. Okay, so to get to this Grignard reagent, you will use magnesium, and you can use ether as a solvent. Okay, and you will get your desired product. Once again, guys, the most important thing is this Grignard reagent is extremely susceptible to humidity or acid environments. So therefore, this magnesium bromide, the salt, will be replaced by a deuterium atom. Okay, will be replaced by a deuterium atom. That is how you do this. All right. So here is your formal answer. All right. The other thing that I want to talk about is a very simple reaction that Grignard reagents undergo in the presence of alkyl halides. Okay, you will talk about, we will go through this reaction in more detail later on, but especially since I am going to use this reaction in the next few example questions. Okay, I'm going to teach you a reaction between a Grignard reagent and an alkyl halide. Okay, so let's take a general Grignard reagent. Let's call it R minus as the carbon ion, and then you will have magnesium X, okay, as this magnesium salt part. Okay, and then when you react a Grignard reagent with an alkyl halide, so let's call it R X, okay, that is our alkyl halide. So when you react these two, what happens is that, okay, it will go through a substitution reaction. And in fact it will be a nucleophilic substitution. Why? Because Grignard reagent or carbon ion in the Grignard reagent is an excellent nucleophile. Okay, this R minus is an excellent nucleophile, so it will basically replace, it will basically attack the carbon and then replace the halogen. Okay, it will replace the halogen. So let's put this as a Cl. Okay, it will replace the halogen, and then what you get is something like this, R CH2 Nu. Okay, so in here what happens is that the nucleophile will attach to the other R group, so you will have a excuse me, so let me use the correct colors so that you will understand it better. So R from the carbon ion, okay, carbon ion will be directly connected to the R group from the alkyl halide, okay. So this is a very nice substitution reaction which will basically couple R groups. Okay, so you can say that this is a coupling reaction. You can say that this is a coupling reaction. So let's get a real-time example here. Let's take a real-time example here. Let's use CH3 MgBr. Here is our Grignard reagent, and then we will use something like, let's say, CH3CH2Br or Cl. Okay, so here is our alkyl halide. So when you combine these two, what you get is a coupled organic compound. Okay, your CH3 group will substitute the chlorine from the alkyl halide. So what you get is this CH3 CH2 CH3. Okay, of course the byproduct is not important, but I can write it down. It will be MgBrCl. Okay, that will be the byproduct. Okay, but that is not that important. Okay, but this will be the organic compound that you will get. Of course, in the future we are going to learn many other reactions that Grignard reagents will display due to its nucleophilic carbon ion. Okay, due to its nucleophilic carbon ion. So with that, I'm going to conclude this video. So if you have any questions, just let me know. Okay, you guys have a nice one. Take care.